In the last video, we talked about how many functions there are from a set of m elements, as in monkey, to a set of n elements, as in neighbor, and we came up with n as a neighbor to the mth power. So we came up with, for that one right there, we came up with n to the m, like so. So down here, remember this was the number of elements in the domain, codomain, make that right, codomain, the possible choices for each of the elements in A, and the number m is the size of A, the domain. Only works for finite cases, of course. Now we're going to answer the second question. How many of these functions are one-to-one? So I'm going to scroll down and get a new page to start out with that. How many of these are one-to-one? So the same sort of scheme is going to work out here. In other words, to determine the function, remember what we're trying to say is, okay, what happens to A1? We have B1, B2 through B sub n, and A1, A2 through A sub m, like so. And so we're still going to do the same thing. In other words, we're still going to try to figure out, okay, what happens, where does A go, A1 go, where does A2 go, etc. Where does AM go? And so each one of these will give us a slot and a choice to make. So let me go ahead and create that. What are the number of choices for the output values of the function? AM is the last one here. What are the choices? How many assignment choices do I have for A1? F of A1 has how many choices? N choices. We can draw that arrow to n different places, and so there are n choices here. Now this function has to be one-to-one, so for A2 there are no longer n choices. We've already used one of them for A1, so now this has to be, this would have to be n minus 1 choices. And similarly, when we get to A3, the number of choices left now are n minus 2. So when we get to AM, how many choices are left? How many have we used? We've used m minus 1 so far. So it will be n minus m minus 1 choices right there. So it's that product there. There are n times n minus 1 through n minus, if I clear parentheses, that's m plus 1, like so. One-to-one functions from A to B. There are that many ways that we can make the assignments so that no element of B gets used more than once. Some of them might not be used at all, but none of them gets used more than once, so it's a one-to-one function. And so that's just a nice quick way. We can count one-to-one functions pretty easily. We can count the total number of functions pretty easily. You may remember from earlier courses that you talked about onto functions, which use every element in the codomain. Counting those is a little harder. We will do that, but we need some other techniques before we get to that. So I will close this video with that comment.